So moving on to the next set of trig graphs that we're going to look at, which would be the tangent function, the cotangent function, the cosecant function, and the secant function. We've already looked at the graphs of the sine and the cosine function, and I think what you'll see as we kind of move into some things with the tangent and the reciprocals, these graphs are, from a mathematical standpoint, a little bit easier to make than some of the different things that we did with sine and cosine. So graph of the tangent function, just talking about some properties of the tangent function. So the period, one of the more notable differences between sine and cosine with tangent, the period is pi. So if you recall, when we were working with sine and cosine, the period for those functions was 2 pi, and the formula for period when we were working with sine and cosine was 2 pi over b. For tangent, the formula for period now is just pi over b equals pi over b. And that's going to come into play heavily when we start to look at some different things with graphs of the tangent and the cotangent. The range goes from negative infinity to positive infinity. The domain for the tangent function is all real numbers except at values of pi over 2 plus n times pi. So that would mean anytime you have the tangent function, the domain is all real numbers except for values like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So it's pi over 2 and any values that you would get by either adding or subtracting pi consecutively to pi over 2. The tangent graph also has vertical asymptotes at pi over 2 and any values that are plus or minus pi from pi over 2. Tangent function is odd, which means it's symmetric to the origin, which we have here. So as far as some different things with how the tangent graph looks, and this is the original tangent graph before we do any stretching, shrinking, shifting, or flipping. So up top here you have a table of values, and just pay close attention to the values that are undefined here. That's where the asymptotes occur on the graph. So you notice here at values of pi over 2, which is this asymptote here, and then any value where you would add or subtract pi, like 3 pi over 2, or negative pi over 2, or even negative 3 pi over 2, those would all be asymptotes on the graph. So when we're talking about the graph of the tangent function, one of the things that we're going to look at first is where do the vertical asymptotes go on the graph. And then the other thing to kind of notice about the tangent graph is the graph has x-intercepts at the midway point or the midpoint between two consecutive asymptotes. So we'll talk a little bit about mathematically where those values come from. And then also just notice the shape in between the asymptotes. It's sort of like that chair-like cubic shape that we did from back when we were talking about graphs of some other types of functions. So this is not a cubic, it's just sort of a chair-like shape that runs in between the asymptotes there. So just some of the different things with asymptotes. So two consecutive asymptotes can be found on the tangent graph simply by solving these equations here. So we have bx minus c equals negative pi over 2, and bx minus c equals pi over 2. And this can also be, or this could be plus or minus depending upon what we have there. So the midpoint between two consecutive asymptotes is an x-intercept, and the period of the function is simply defined by the distance between two consecutive asymptotes. So if you recall when we were talking about sine and cosine, the period was defined by the horizontal distance that it took for the graph to make one full cycle. For a tangent graph, the period is simply just defined by the distance between two consecutive asymptotes. So if you take this first example here, so with this first example, we have sketch the graph of y equals the tangent of x over 2. So as far as the b value here, I can rewrite this equation as y equals the tangent of 1/2 x. So that gives me a b value here that's 1/2. So as far as the period for this goes, the period for this I'm going to find by dividing pi over b. So in this case I'm going to do pi divided by 1/2, which would be 2 pi. So this graph has a period that's 2 pi. So the distance between two consecutive asymptotes here is going to be 2 pi. So as far as finding where one set of consecutive asymptotes occurs on the graph, I'm going to take this part of the equation here, this 1/2 x, and I'm going to set it equal to negative pi over 2. And the reason that I'm doing that, if we come back to this right here, I'm basically going to use these two asymptotes as the basis for what I'm going to use to find two consecutive asymptotes. And I'm picking these two because I think it would be easiest to remember where these two asymptotes occur on the graph. You have negative pi over 2 and positive pi over 2. There are others that are consecutive, but I picked these two because I thought these would be two that would be easiest for you to remember. So as I come back to here, when I go to solve this now, I have 1/2 x equals negative pi over 2. So when I divide both sides by a half, I end up getting negative pi as a result. So that's one of the asymptotes that's on the graph. Then when I take 1/2 x and I set it equal to pi over 2, and I'm doing that because that's the next consecutive asymptote on the graph. So here's negative pi over 2, here's positive pi over 2. So when I go to solve this now, I get x equals pi. And if you notice, the distance from negative pi to positive pi is 2 pi. So that kind of gives me an idea if mathematically what I'm doing here is in fact correct. So if we're talking about the graph for this now, and I'm going to kind of draw this here. So here's negative pi, let's say. Here's positive pi. And here are the asymptotes that go through those 2 points. So the midpoint between negative pi and pi would be 0. So I'm going to put an x-intercept right here. So if we're talking about formula for midpoint, and I'll put this up off to the side here, but if you, sometimes you can tell what the midpoint is just from looking at the graph, but if you can't, remember that formula for midpoint is you can take your two endpoints and you can add them and divide by 2, and that will give you what the midpoint is between 2 points. So that makes the midpoint of this here 0. And then all I want to do is I want to kind of just draw this chair-like shape to go through that point right there. So that's one full cycle for the tangent graph. Now, if I wanted to continue this graph, say for a second cycle, maybe to the right of this asymptote here, all I want to do is just take my period, which in this case was 2 pi, that's this here, and all I would do is I would add 2 pi to this asymptote that's on the right here. So if I did 2 pi plus pi, I would get 3 pi, which I can put here. And then the midpoint between pi and 3 pi would be 2 pi. So that would go here. And then once again, I would just draw a chair-like shape. Actually put my asymptote through that point there. I would just draw a chair-like shape that goes through the point there. Now if I was to go in the other direction, I know I'm kind of running short on room here, but if I was to say to draw another asymptote that was to the left of negative pi, I would minus 2 pi from this, so this would be negative 3 pi. And I would have another asymptote that went through that there, and the midpoint between those two would be negative 2 pi. And I would once again just draw my chair-like shape through the point there. So that's essentially the math that's involved with the tangent graph. So if I could bring you back to here, here's sort of a more cleaned up version of what that graph looks like. So this is basically this right here. This is kind of what we just drew there. And you can see where the asymptotes occur, and you can see where the x-intercepts are and what the shapes are in between the graphs. Very similar to what we just drew there. So that's example 1. Example 2, I have y equals negative 3 tangent of 2x. So a couple things to keep in mind here. First is I'm still going to do period. And I'll deal with this whole negative 3 business once we get to the drawing of the actual graph. So the period for this, I'm going to do pi over b, which in this case will be pi over 2. Now when I go to do the where the asymptotes occur, I'm going to take this right here, the 2x, and I'm going to set it equal to negative pi over 2. When I solve that for x, I get negative pi over 4. Then when I take this 2x here, and I'm going to set it equal to pi over 2. And when I solve that, I get positive pi over 4. So if you notice, the distance from negative pi over 4 to positive pi over 4 is in fact pi over 2. So once again, just something you can do to kind of check yourself to see if what you did was right there. So as far as the graph for this goes, so I'm going to take this here, give myself some room on both sides of the y-axis here. So I have, here's negative pi over 4. So I got a vertical asymptote that goes through there. Here's positive pi over 4. The same thing, I got a vertical asymptote that goes through there. Now the midpoint between these two is once again going to be 0. So that's here. So before I draw my curve, let me kind of speak to this negative 3 that's in front of the function. So keep in mind that the negative, okay, here is going to take the graph and it's going to flip it upside down. So instead of having sort of that up over up shape, this is going to kind of have like a backwards chair shape that's down over down. And then the 3 that's in front of the function, remember that putting a 3 in front of the function is going to vertically stretch the graph. So what I want to do when I draw my chair-like shape through this point, I want to draw it so it's a little bit closer or tighter to the y-axis than what the previous graph was. And notice I'm drawing this upside down. I'm drawing it as more of a down over down type graph rather than an up over up type of graph. So that essentially counts for the fact that it's upside down, and because I'm drawing it a little bit tighter to this y-axis, that essentially counts for the fact that the 3 in front of the function is going to vertically stretch the graph. So if I wanted to continue this graph in both directions, remember that the period for this would be pi over 2. So if I were to take pi over 4 and add pi over 2 to it, I would get 3 pi over 4. And if I drew an asymptote here, and then if I put my x-intercept in the middle, pi over 4 and 3 pi over 4, the midpoint there would be pi over 2. And I would have, once again, an x-intercept there, and then I would just draw a chair-like shape that would be very tight to that pi over 2 that I made on the graph there. So that would be another full cycle of the tangent graph to the right. If I went over here to the left at negative pi over 4, if I wanted to draw another cycle of the graph to the left of that, if I took negative pi over 4 and I subtracted pi over 2, I would get negative 3 pi over 4. And I'd have a vertical asymptote that goes here. And then the midpoint between negative 3 pi over 4 and negative pi over 4 would be negative pi over 2. And that's where my x-intercept would go, and then I would draw that tight chair shape that runs through the point there. And I could continue this in both directions simply by just taking the asymptotes that I have on the far left and the far right and just adding pi over 2 to those again, and then I could use those to graph another full cycle. So that's the tangent graph. The cotangent graph, a lot of similarities to the tangent graph in that the period for this is pi, the range for this is negative, from negative infinity to positive infinity. Biggest difference between the two graphs, and there's two notable differences. One is the domain and where the vertical asymptotes occur. So the domain for this is all real numbers except for values of pi, meaning you would have a vertical asymptote at 0, which would be the y-axis, and then after that they would occur at values of pi, like pi and 2 pi and 3 pi, and also in the negative direction, negative pi, negative 2 pi, etc., etc., etc. And just note here, the y-axis serves as a vertical asymptote. So when we're sketching the graphs for this here, so here I got sketch the graph of y equals 2 times the cotangent of x over 3. One thing I failed to mention about this graph, let me just sort of erase some of the notations here, but notice the shapes that are in between the asymptotes here. Notice it's a sort of a backwards like chair shape. It's sort of a down over down type of shape that goes in between the asymptotes there. So that's of significance when we go to draw the curves after we plot our asymptotes and x-intercepts at the end. So example 3, we have y equals 2 cotangent of x over 3, which I'm going to rewrite as y equals 2 cotangent of 1/3 x. So when I go to do the period here, I'm going to do this as pi over 1/3, which in this case would be 3 pi. So that's the value of the period there. Now I'm going to find where the asymptotes occur. So I'm going to use, in this case, I'm going to take this 1/3 x, and I'm going to set this equal to 0. And I'm going to use these two asymptotes on the graph, this one here and this one here, as my two consecutive asymptotes. And we're going to use those to kind of get started, and then we will, similar to what we did with the tangent graph, we will graph other cycles of the cotangent using these two asymptotes and what the period of the function is. So if I solve this, I get x equals 0. So that's where the first asymptote is going to occur on this graph. And then I'm going to take 1/3 x and I'm going to set it equal to pi, because that's the next consecutive asymptote that's to the right of the y-axis. And when I solve this, I get x equals 3 pi. So now that's where the two consecutive asymptotes, or the first two that we're going to use, that are going to occur on this graph. So when I graph this, so I'm going to put this in the middle here. So I have one vertical asymptote, that's the y-axis, so I got this here. And then I have another one at 3 pi, and that's going to go here. So if we're talking about the midpoint between these two asymptotes, so the midpoint between pi and 3 pi would be 3 pi over 2. And then if you notice with this, I have this 2 that's in front of the function. So similar to what we said from the second example, that 2 is basically just going to vertically stretch the graph. So when I draw my chair-like shape in between the 2 points there, I just want to draw those so it's a little bit tighter to the 3 pi over 2 than say it is to the asymptotes. So if I wanted to graph some more cycles of this, say if we went to the right of 3 pi over 2, all I would do is I would take that 3 pi and I would add the period to it. So the period here is 3 pi. So I'm going to take this and I'm going to add 3 pi to 3 pi, which when I do that I get 6 pi. And here's another vertical asymptote. So in between these two, if I have 3 pi and 6 pi, this would be 9 pi over 2. That would be the midpoint between those two there. And then here's my chair-like shape that runs through that point there. Then if I was going to draw a full cycle to the left of this asymptote here, if I did 0 minus 3 pi, I would get negative 3 pi, so that would go here. I'd have a vertical asymptote like that. And then the midpoint between negative 3 pi and 0 would be negative 3 pi over 2. And that's where the x-intercept would occur. And then here's the chair-like shape that kind of runs through that point there. So you basically have something like that for that cotangent graph. So those are the graphs of the tangent and the cotangent. I think you can see there's a lot of similarities that they have in terms of asymptotes on the graph and what their shapes are and how you find their x-intercepts. And I think you can also see here that mathematically speaking, there's a lot less involved with making these graphs than, say, what there was when we did the sine and the cosine. And what we're going to look at next is how to graph the cosecant graph and how to graph the secant graph as well.